Have you ever wondered why atoms combine? From the water you drink to the salt on your fries, atoms are constantly at work forming the world around us. Let's explore why atoms combine and uncover the secrets of the octet rule. Why do atoms combine? Atoms combine with each other to form various compounds. The smallest unit of a substance that can exist independently is called a molecule. So when atoms combine, they form molecules. The chemical behavior of an element depends on its position in the periodic table, which is linked to its electronic configuration. The reactivity of an element depends on how its electrons are distributed. Atoms with a total of 2, 10, 18, 36, 54, or 86 electrons are the most stable. These are noble gases, and they all have 8 electrons in their outermost shell, except for helium, which has 2. Other atoms, with less than 8 electrons in their outermost shell, are reactive. For example, sodium has just 1 electron in its outer shell, while chlorine has 7. Because neither has 8, they're both quite reactive. When sodium transfers its electron to chlorine, both atoms achieve stability. Sodium becomes a positively charged ion, and chlorine becomes negatively charged. Together, they form sodium chloride, or table salt. Octet Rule. In 1916, scientists W. Kossel and G. N. Lewis observed something fascinating. During chemical reactions, atoms tend to rearrange their electrons to achieve the configuration of noble gases. This is known as the Octet Rule. It means that during chemical reactions, atoms strive to have 8 electrons in their outermost shell. This rule explains why atoms react to gain, lose, or share electrons. For hydrogen, stability means having just 2 electrons in its only shell. It can lose its 1 electron to become H+ or gain an electron to become H-. Atoms gain stability by transferring electrons. Fluorine, for instance, has 7 electrons in its outer shell. By gaining 1 more, it completes its octet, transforming into a fluoride ion with the stable configuration of neon. Alternatively, 2 fluorine atoms can share their unpaired electrons, forming a bond. This sharing allows both atoms to complete their octet, creating a stable fluorine molecule. Exceptions to the octet rule. The octet rule isn't universal. For example, in phosphorus pentachloride, PCl5, phosphorus has 10 electrons in its outer shell. In sulfur hexafluoride, SF6, sulfur has 12. These molecules are stable, even though they break the octet rule. Chemistry is full of exceptions, and that's what makes it so fascinating. Closing. So, the next time you use table salt, drink water, or marvel at neon lights, remember the octet rule. It's the key to understanding how atoms combine to create everything around us.